So let's take a look at number 1. So it says state of each sequence is arithmetic, geometric, or neither. So first thing we want to check, what are we adding to get from one number to the next? And then what are we multiplying to get from one number to the next? To check and see if it's arithmetic, because arithmetic is adding, geometric is multiplying. And then if we're not adding something constantly or multiplying something constantly, then it's going to be neither. So what are we adding to get from 7 to 97? 90. Are we adding 90 to get from 97 to 997? No. So it's not arithmetic. Now let's check geometric. What are we multiplying to get from 7 to 97? It would be, we could do 97 divided by 7, which I don't think it simplifies. But are we multiplying the same thing to get from 97 to 997? No. So is this arithmetic, geometric, or neither? Neither. Let's look at number 3. So what are we adding to get from negative 20 to negative 12? We're adding 8. Are we adding 8 to get from negative 12 to negative 4? Are we adding 8 to get from negative 4 to positive 4? So is this arithmetic, geometric, or neither? Arithmetic. Once you check and see if it's arithmetic, you're adding the same thing over and over again. You don't have to check and see if it's geometric because it's not going to be both. Once you know it's arithmetic, you're done. See number 5. What are we adding to get from 2 to 5? Adding 3. Are we adding 3 to get from 5 to 10? No, we're not. So it's not arithmetic. Let's check multiplying. What are we multiplying to get from 2 to 5? 5 over 2. We just take the second term divided by the first one. If we multiply 5 by 5 over 2, do we get 10? No. So is this arithmetic, geometric, or neither? Neither. To find what your common ratio is, you always take the second term and divide it by the first. So that's what we multiply to get from 2 to 5. But if you look here, to get from 5 to 10, we're multiplying by 2. We're not multiplying by 2 here, so it's not. So number 7. What are we adding to get from 3 to negative 10? Negative 13. Are we subtracting 13 to get from negative 10 to negative 23? Yep. And what about from negative 23 to negative 26? Negative 36. Yep. So what is this? Arithmetic. And number 9. What are we adding to get from 4 to negative 16? We're multiplying by negative 4. Are we multiplying by negative 4 to get from negative 16 to 64? Yep. And again here, negative 4. Yep. So what is this? Geometric. Any questions on these? All right, let's take a look at number 11. We have to find the common difference, the rule, which is the formula, and give the term of the arithmetic sequence. So find the common difference first. What are we adding to get from negative 27 to negative 34? Or subtracting? We're subtracting 7. Are we subtracting 7 here? Yeah. Yep, and here too. So our common difference is negative 7. What's our first term? negative 27, just the first one on the list. So our rule, our formula, is a sub n is equal to our first term, so negative 27 plus n minus 1 times the common difference, which is negative 7. That's our rule. Now it wants us to find the 36th term. So what are we plugging in for n? 36. So a sub 36 is equal to negative 27 plus 36 minus 1 times negative 7. What do we have to do first? The parentheses. So negative 36 minus 1 would be 35. What do we do next? (35) times negative 7, which would be negative 245. So negative 27 minus 245, what do we get? Negative 272. Awesome. So our 36th term is negative 272. You guys can use a calculator for these types of questions. Just be careful when you're putting it in the calculator. All right, let's take a look at 13. So we want to find our common difference, our first term, and then put everything into our formula. So what's our common difference? What are we adding to get from one term to the next? We're adding 5. So plus 5, plus 5, plus 5. What's our first term? 23. Now, we need our formula, so a sub n is equal to our first term, which is 23, plus, what comes next? Well, before we do 32 minus 1, we just say n minus 1, because this is just our general formula, and then we multiply that times d, which is 5. Now we can plug in 32. Once we have our general formula, we can plug in 32. So 23 plus 32 minus 1 times 5. What do we have to do first? 32 minus 1. So that would be 31 times 5 plus 23. What do we do next? (31 times 5), which is 155. And then 32 plus, or 23 plus 155. That gives us a sub 32 is equal to 178. Any questions on this one? All right, let's look at 15. What's our common difference? Negative 7. We're subtracting 7 here, subtracting 7 here, subtracting 7 here. So our common difference is negative 7. What's our first term? 9. So let's plug that into our general formula. We have a sub n is equal to our first term plus n minus 1 times negative 7. What are we plugging in for n? (39). So 39 minus 1 times negative 7. What do we have to do first? (39 minus 1). So 38 times negative 7 plus 9. What do we have to do next? Multiply 38 times negative 7. That gives us negative 266. So 9 minus 266. What'd you guys get for your answer? Negative 257. Awesome. So our 39th term is 257. All right. For the next section, these are geometric ones. So we have to find the common ratio, the rule, which is our formula, and the given term. So what are we multiplying to get from 2 to negative 4? Negative 2 to negative 4. What's negative 2 times negative 2? It should just be positive 2. So we're multiplying with positive 2. Got to be careful with the signs. This one's a little bit tricky. So our ratio is 2. What's our first term? Negative 2. So our formula for a geometric sequence is a sub n is equal to our starting term times our ratio, so times 2 to the power of n minus 1. What are we plugging in for n here? 10. So negative 2 times 2 to the power of 10 minus 1. What do we have to do first? Ten minus 1. So we have 2 to the power of 9 times negative 2. So 2 to the power of 9 is 512. Then we have 512 times negative 2. What do you guys get for your answer? Perfect. Negative 1024. Awesome. All right. 19. What's our common ratio? Negative 3. You can always find the common ratio. If you don't know what you're multiplying to get to the next, just take the second term, divide it by the first. So 12 divided by negative 4 is negative 3. What's our starting term? Negative 4. So we plug that in. We have a sub n is equal to starting term times our ratio to the power of n minus 1. What are we plugging in for n here? 9. So negative 4 times negative 3 to the power of 9 minus 1. What do we have to do first? Nine minus 1, which is 8. So then negative 3 to the power of 8. Perfect. And that times negative 4. Awesome. Negative 26,244. That's our 9th term. Any questions here? All right, last one, 21. What's our common difference, or our ratio? Negative 6 over 3, which is? Negative 2. And what's our first term? 3. So plug that in. We have a sub n is equal to positive 3 times negative 2 to the power of n minus 1. What are we plugging in for n? 9. So 3 times negative 2 to the power of 9 minus 1. What do we have to do first? Subtract 9 minus 1, which is 8. So negative 2 to the power of 8. It's actually, it's positive 256. So if you're putting it in the calculator, you want to make sure, if you use a calculator, you need to use parentheses. If you're using the phone calculator, just be careful. One way we can tell is we're looking for the 9th term. So if we look, our first term is positive, our third term is positive, our second term is negative, and our fourth term is negative. So all of the even terms are negative, and all of the odd terms are positive. So a sub 9, is that even or odd? Is 9 even or odd? It's odd, so it's going to be positive. So whenever your ratio is negative, just be careful, and you can always check your signs at the end, because they're always going to alternate. It'll go positive, negative, if your ratio is negative. So here we get negative 2 to the 8th power is positive 256, and then that times 3. So what'd you get for your answer? 768. Awesome.